Hello students, our today topic is 555 timer IC. A number of integrated circuits designed for specific applications are available as monolithic ICs. This 555 timer is one such monolithic IC. 555 timer IC. The 555 timer IC is a highly stable device for generating accurate time delay or oscillation. It is introduced by Schematic in 1972. Most popular is NE555 by STM Electronics and Fairchild Semiconductor. The 555 timer IC is an integrated circuit used in a variety of timer, pulse generation, and oscillator applications. The 555 timer is used to provide time delays as an oscillator and as a flip-flop element. It gets its name from the 5K ohm resistor and which gives the two comparators a reference voltage. Depending upon the manufacturer, a standard 5K package includes 25 transistors, 2 diodes and 15 resistors on a silicon chip installed in an 8-pin dual inline package. It is available in low power CMOS type ICM 7555 package and 556 dual timer with 2 timer in one IC and 5558 which is in quad package. So the IC 555 is the most versatile linear integrated circuits introduced by Schematic Corporation. This is a monolithic timer IC which can be used for many timer applications such as monostable and astable multivibrators, linear ramp generator, missing pulse detector, automatic battery changer, etc. A single 555 timer can provide time delay ranging from microseconds to hour, whereas counter time can have a maximum time ranging of days. The 555 timer is an integrated circuit designed to perform signal generation and timing and specific timing. The 555 timer can be used with supply voltage range of plus 5 volt to plus 18 volt and can draw load up to 200. It is compatible with both TTL and CMOS logic circuits and op-amp based circuits. Because of wide range of supply voltages, the 555 timer is versatile and easy to use in various applications. So the applications of 555 timer include oscillator, pulse generator, ramp and square wave generator, monoshot multivibrator, Barker alarm, traffic light control, voltage monitor, etc. So this is the functional block diagram of a 555 timer or the internal layout of a 555 timer. The 555 timer integrated circuit is available in 8-pin circular type, 8-pin mini dip and 14-pin dip. The 555 IC is widely popular and various manufacturers provides the IC. So it has 8 pins starting from ground to plus VCC power supply. So ground, trigger, output, reset, control voltage, threshold, discharge plus VCC power supply here. First one, internal layout. It has the positive DC power supply terminal is connected to pins VCC and negative terminal is connected to pin 1 that is ground. The ground pin acts as a common ground for all voltage references while using the IC. The output 3 can assume a high level or a low level. Also, there is a 3 5K ohm internal resistors acts as a voltage divider providing bias voltage of 2 by 3 VCC to the upper comparator and 1 by 3 VCC to the lower comparator. Since these two voltages fix the necessary comparator threshold voltage, they also aid in determining the time interval. A control voltage input terminal, that is pin 5, accepts a modulation control input voltage applied externally. The positive input terminal of the upper comparator is called threshold terminal, and the negative input terminal of the lower comparator is called the trigger terminal. So this is the overall pin of a diagram of a 555 timer IC. So now we can see the important parts of an 555 timer IC. It has a voltage divider network. Resistors R1, R2 and R3 are connected in series. Each resistor is 5k ohms. So 1/3 of the 5 volt supply voltage drops across each one. Hence, the voltage at this point is 1 by 3 VV and the voltage drop at this point is 1 by 3 V. Next one is the voltage comparator. Voltage comparator, we have two voltage comparators inside the 555 IC. Whenever the voltage is higher at the positive input, the output value is positive. The output is 0 volts under all other conditions. So this is the upper comparator and this is the lower comparator for greater than 3.3 voltages, and here it is 3.33 voltage, here it is 1.65 voltage. Next one is the flip-flop. Here we use a RS flip-flop. Whenever the output of the comparator A is positive voltage, then the Q bar is becomes a positive voltage, which is logic high. Hence, this comparator uses a truth logic table according to which the output may varies. Next one is the discharge transistor. The NPN transistor acts as a switch. Here it turns on and passes the current between the emitter and the collector when a positive voltage is present at the base. So next one is the output buffer. Output buffer. The output buffer produces a high current voltage which provides sufficient output to power externally circuit. The output buffer receives its input from the Q bar output of the RS flip-flop. The buffer output goes positive when the Q terminal of the RS flip-flop is a logic low. The output of the buffer approaches 0 volts when a logic high is produced at the Q bar output. Next one is the pin description. Pin 1. The ground pin connects the 555 timer to the negative supply rail. Pin 2. Trigger. When less than 1 by 3 VCC, that is active low, this makes the output high. It monitors the discharge of the timing capacitors in an unstable circuit. Pin 3 output. The output pin can drive any TTL circuit and is capable of sourcing or sinking up to 200 milliamps of current at the output voltage. Pin 4 reset. When less than above 0.7 volt, this makes the output lower. Next one is the pin 5 control voltage. This can be used to adjust the threshold voltage, which is internally to be 2 by 3 VCC. Pin 6 threshold. When greater than 2 by 3 VCC, this makes the output low. Pin 7 discharge. The discharge pin is connected directly to the collector of an internal NPN transistor. Pin 8 is the supply voltage. This is the power supply pin, and for general purpose it is between 4.5 volt and 15 volt. 18 volt about maximum. So modes of operation. It operates in three modes. One is monostable, next one is bistable, and astable. Astable is the free running mode. It has no stable states. Monostable has only one stable state, and bistable has two stable states. So it is used in applications like blinking LED lights, police car sirens, a light detector, mosquito repellent, railway lights. Thank you.